Proving trig identities is an introduction to mathematical proofs. From the trigonometric identities that we already know, we're able to show many more such trig identities. To verify that a trigonometric equation is in fact an identity, we transform one side of the equation into the other side. Let's go ahead and look at an example of proving a trig identity. For this identity, we want to show that tan x plus cotan x squared is equal to secant squared x plus cosecant squared x. So let's go ahead and simplify the left-hand side. We'll factor this out and get a tan squared x plus 2 tan x cotan x plus cotan squared x. Simplifying this, we'll leave our tan squared x alone and our cotan squared x alone, and rewrite our 2 tan x times cotan x as 2 tan x times 1 divided by tan x. The tan x's cancel out, and we're left with a tan squared x plus cotan squared x plus 2. Now we can replace our tan squared x with a secant squared x minus 1 and replace our cotan squared x with a cosecant squared minus 1. This gives us secant squared x minus 1 plus cosecant squared x minus 1 plus 2. And now we see this -1, -1, and 2 cancel out, and we get that secant squared x plus cosecant squared x. And we just showed that the left-hand side of our equation is in fact equal to the right-hand side using different trig identities. So we're done. Let's go ahead and look at some helpful hints for proving trigonometric identities. So you want to start off by looking at one side of your equation, writing it down, and just trying to simplify this as much as you can. Once you've done this, step number 2, generally you want to use well-known trig identities already, the ones that we've seen in the first part of this lecture, to further simplify our trigonometric equation. Step number 3, if you can't get anywhere, then it's generally helpful to rewrite all our functions in terms of sine and cosines, and then use the trig identities that correspond to sine and cosine. And finally, if you can't solve the trig identity, go ahead and start simplifying the other hand side. If you can simplify the right-hand side and the left-hand side to equivalent expressions, then you've also verified your trig identity. So let's go ahead and work a few more problems. Now, let's go ahead and verify the following 2 trig identities. In part A, we want to verify that cosine u times secant u divided by tan u is equal to cotan u. So let's rewrite the left-hand side real fast. This is going to give us cosine of u times secant u divided by tan u. And let's rewrite this expression in terms of sine and cosine. This is going to be cosine of u times 1 divided by cosine of u divided by sine of u divided by cosine u. So simplifying the top, we get that this is going to be 1 over sine of u divided by cosine of u, which is equal to cosine of u divided by sine of u. And this is equal to cotan u. And we're done. We showed that the left-hand side of the equation is equal to the right-hand side of the equation. Now let's go ahead and look at part B. We want to verify that 1 minus cosine squared x times 1 plus cotan squared x is equal to 1. So let's go ahead and FOIL out the left-hand side, and we should get that this is going to be a 1 plus cotan squared x minus cosine squared x minus cosine squared x times cotan squared x. Now, while we've done nothing wrong yet, it doesn't look like this will be a very simple way to verify that this is a trig identity. So what we should do is we can try a different route. let's go ahead and replace this 1 minus cosine squared x with a sine squared x. So instead we'll get sine squared x times 1 plus cotan squared x is still equal to 1. Multiplying out the sine squared x, we get sine squared x plus sine squared x cotan squared x is equal to 1. Sine squared x and cotan squared x simplifies just to be cosine squared x. We still have our sine squared x, and we know that this is equal to 1. And so we've verified our trig identity.